Okay, good morning all of you. Yesterday we seen completely or we learned about the molecular orbital theory. Today we will see about the hydrogen bonding. Listen all of you carefully, what is the meaning of hydrogen bonding and what are the effects of hydrogen bonding in chemicals. We will see all these things. So to understand a hydrogen bonding, first of all we have to take the water. So water means chemical composition is H2O. In water, what is the situation? Anybody? In liquid water, so many H2O particles will be there or molecules will be there. Can be taken as HOH like this. One water molecule. Take another water molecule like this. Yes or no? Yes. So between H2O and H2O, what happening in water we have to study. That is only nothing but hydrogen bonding. So observe here very carefully, between hydrogen and oxygen unequal sharing is happening while hydrogen electronegativity 2.1, oxygen electronegativity 3.5. That's why the shared pair is very nearer to the oxygen. Then we are getting partially negative charge. Here we are getting partially positive charge. Concept is calling as a polar covalent bond. Same situation also happening here, partially positive charge, partially negative charge. Anyway, it is the polar molecule and it is also polar molecule. Okay, now how these two water molecules are connected together or attracted together. So this is negatively charged oxygen atom and positively charged hydrogen atom having some force of attraction between them, that only we are calling as hydrogen bonding. Okay, anybody, can you tell me what is the definition of the hydrogen bonding? Hydrogen bonding means a force of attraction between positively charged hydrogen atom and negatively charged highly electronegative element, may oxygen or nitrogen or fluorine. Such force of attraction only we are calling as hydrogen bonding. I will write the definition here. See, force of attraction between positively charged hydrogen atom and a negatively charged highly electronegative element, may fluorine or oxygen or nitrogen, is called hydrogen bonding. Okay, can I give you one more example for hydrogen bonding existing material? Yes, you take liquid ammonia. What is the situation? Ammonia, you already learned in the Vesper theory, it is in the pyramidal in shape. Yes, you take like this, NH like this, lone pair. This is a one ammonia molecule, this is the another ammonia molecule. Okay, between nitrogen and hydrogen unequal sharing is going on. That's why the nitrogen lone pair is very near to the nitrogen, gets partially negative, hydrogen gets partially positive. This is partially positive, this is partially negative. What I am telling? Partially positively charged hydrogen atom having attraction with negatively charged highly electronegative element is calling as hydrogen bonding. Yes. Are you understanding or no? Now my question, the strength of hydrogen bonding, these are important for competitive marks. Strength of hydrogen bond is directly proportional to electronegativity of combining element with hydrogen. Means, for example, in water, hydrogen bonding, or if you can take HF means, for example, in HF the hydrogen bonding is where between hydrogen atom and fluorine. In water, hydrogen bonding between hydrogen and oxygen. In ammonia, hydrogen bonding between hydrogen and nitrogen. Out of all are hydrogen bonds only, but which is the strong? How can you tell? The strength of the hydrogen bonding is directly proportional to electronegativity. You know, highest electronegativity having by fluorine, and oxygen will be 3.5, nitrogen will be 3. So that's why this is the more strength than these all. So that's why HF is the very denser liquid than NH3, than H2O, than NH3. And one more thing I want to tell, see, very important point. If you take water, in water what is the situation? HOH will be there and HOH will be there. Yes, between water molecule what happening? Hydrogen bonding is operating. Already in the water molecule, what is there? OH covalent bond is there. This is purely covalent bond and this is hydrogen bonding. Can you guess, in water OH covalent bond and in between water OH hydrogen bond, which is stronger? Covalent bond is stronger than the hydrogen bond. That all I am writing here. Strength of O hydrogen bonding, this is nothing but hydrogen bonding, is weaker than strength of OH pure covalent bond within the same molecule. So what we can tell, for example, you take a water, in water OH bond is there, that is a covalent bond. In between water molecule hydrogen bonding is there. In between water molecule whatever hydrogen bonding will be there, that strength should be, or that will be weaker bond than OH bond which is present in the water molecule. Same we can tell here, NH hydrogen bonding is weaker than NH pure covalent bond which is present inside the molecule. Are you getting or no? What is the meaning of hydrogen bonding? The force of attraction between positively charged hydrogen atom and always highly electronegative element, nothing but negatively charged particle, either fluorine or oxygen or nitrogen, is calling as hydrogen bonding. Always hydrogen bonding strength is directly proportional to electronegativity. The strength of the hydrogen bonding is always weaker than the strength of the pure bond which is present inside the molecule. All of you understanding? Now I will discuss about the types of the hydrogen bonding. Next concept is nothing but types of hydrogen bond. We have two types of hydrogen bonding. First we will see what are those and later we can discuss. Intermolecular hydrogen bonding, intermolecular hydrogen bonding. Another one is intramolecular hydrogen bonding. Intramolecular hydrogen bond. So what is the inter and intramolecular hydrogen bonding? We will discuss very briefly regarding each type. First one I am explaining about the intermolecular hydrogen bonding. Intermolecular hydrogen bond. Okay, first I will write a definition. What we learned here, there all under comes intermolecular, means is a hydrogen bond between two molecules. Between two molecules, they may be same or different. May be same or different. What is the meaning of intermolecular hydrogen bonding? It is a hydrogen bond formed between two molecules, may be same or different. Yes, the force of attraction or hydrogen bonding is existing between the two molecules. The two molecules may be same or different. Is calling as a intermolecular hydrogen bonding. Easily remember, intermolecular hydrogen bonding like international games. International means what? In between two countries. Are you understanding or no? Like that, remember, international. International means in between the two nations or two countries. Like that, intermolecular hydrogen bonding means hydrogen bonding which is operating between the two molecules. They may be same or different. Okay, can we give this example? First example I am telling water. Water I am explaining. In water, what is the situation? HOH, and like that we can take HOH, and this is the partially positive charge and partially negative. Yes, hydrogen bonding is operating between the two molecules. They are same. They may be same or different. It's not a condition, but between two molecules is calling as a inter. And I will give you example. Liquid ammonia, already we learned. Liquid ammonia means what? You take NH like this, one molecule, partially negative, partially positive. Like that we can take one more molecule, NH and H like this will be there, partially negative, partially positive, another molecule. What may operating between them? A positively charged hydrogen atom having attraction with negatively charged nitrogen atom, calling as hydrogen bonding. Anyway, between two molecules is calling as intermolecular hydrogen bonding. I will give you one more example. HF, hydrogen fluoride. SHF means H and F bond is there, one molecule. You take another molecule of HF like this. Okay, between H and F unequal sharing, partially negative, partially positive, partially positive, partially negative. What we are telling? A positively charged hydrogen atom having attraction with negatively charged highly electronegative element is calling as hydrogen bonding. Anyway, hydrogen bonding between the two molecules may be same or different is calling as a intermolecular hydrogen bonding. I will tell you one more example. Alcohol CH3OH in water. Alcohol in water. Yes, you take alcohol in water, it is undergoing dissolving because of hydrogen bonding. Which hydrogen bonding? Intermolecular hydrogen bonding. That only I am telling here. See, CH3OH, and you know very well H2O will be like this. This is the one molecule and this is the another molecule. They are different. Now what happening between oxygen and hydrogen unequal sharing, the sharing towards oxygen will be more, negative charge, positive charge. Here partially positive charge, partially negative charge, because shared pair is very near to the oxygen. One of the molecule of positively charged hydrogen atom having attraction with negatively charged oxygen atom is calling as hydrogen bonding. That hydrogen bonding is in between the two molecules. They may same or different, calling as intermolecular hydrogen bonding. Are you clear? Just I will tell you some other example for this one is nothing but metanitrophenol. Metanitrophenol. Yes, first of all write down phenol. Phenol means what? On benzene OH is coming. Metanitro, this is ortho position, this is meta position, this is a para position. Meta position having which one? Nitro. Do you know nitro group? NO2 group. Nitro group means is nothing but NO2 group will be there. I will write it here, see carefully, N double bond O and coordinate covalent bond with oxygen. Okay, now I will take one more molecule of this one is nothing but OH and here NO2. N double bond O and coordinate covalent bond with oxygen. Yes, anyway, these are nothing but metanitrophenol. What happening here? Just you check it carefully. This is like a double bond O and coordinate covalent bond with oxygen. We are getting here partially positive and partially negative. Here partially negative and we are getting here partially positive. Same situation, partially positive, partially negative. Here partially positive and partially negative charge you are getting. What happens here? See carefully. Positively charged hydrogen atom having attraction with negatively charged highly electronegative element is calling as intermolecular. One more hydrogen bonding is happens here. Check it clearly. This is the OH, no, partially positive charge, no. Yes, we are getting here also attraction, that is also calling as intermolecular hydrogen bonding because it is operating between the molecules. They are same molecules. No, I will take one more example is nothing but para hydroxybenzaldehyde. Para hydroxybenzaldehyde. I think you learned all these in organic chemistry. You take benzaldehyde, yes, OH and benzaldehyde. Benzaldehyde means benzene plus aldehyde. C double bond O and H, CHO. Para position, ortho meta para position. Take it reverse. Then what we are getting? C double bond OH, benzaldehyde. Para position has OH. This is the one molecule, this is another molecule, but same, let it be. Now here between O and H what happens? Partially positive, partially negative. Here partially negative, here partially positive. Same situation, partially positive, partially negative, partially positive, partially negative we are getting. Okay, anyway, positively charged hydrogen atom having attraction with highly electronegative element is calling as a hydrogen bonding. Coming in between the molecules called as a intermolecular hydrogen bonding. Okay, and here also we are getting association we are getting is nothing but intermolecular hydrogen bonding we are getting. Okay, because of this intermolecular hydrogen bonding, what properties may change? Are you understanding? Yes, means what happening here? So when you consider means in a some materials between the molecules some extra force of attraction will be happening. Because of this one, what properties may change? Just I will tell you effects of intermolecular hydrogen bonding. Effects of intermolecular hydrogen bonding. So one thing we have to observe, because of intermolecular hydrogen bonding, what happening, the molecules are attracted to each other, becoming like a group. Means that only I am telling, because of intermolecular hydrogen bonding, association of molecules is taking place. Association of molecules is happening. Association of molecules means is nothing but groups of molecules is happening. Okay, because of groups, what happening, you automatically the molecules are very close to each other, then so many properties will be changing. What are those? Density of the substance or material is increasing. And one more thing we can tell, its melting point and as well as boiling point is also going on increasing. Why? You have one single student is there and 10 students are set together. So means by applying very less force, we can push easily single person. Okay, but 10 people are hold like this. But if you want to push them, if you want to disturb them, required energy will be high. Same situation happening here because of intermolecular hydrogen bonding. A group of molecules is happening automatically. Melting and boiling point is going on increasing. And I want to tell you here one more thing, because of intermolecular hydrogen bonding, solubility is also increasing. Solubility is also increasing. If suppose you take alcohol and water, if there is no intermolecular hydrogen bonding, is it mixed together? No. Because of intermolecular hydrogen bonding, what happening? Solubility of a liquid in others will be going on increasing. Did you got my point? Yes. Now we have to discuss about the second factor or second type is nothing but intramolecular hydrogen bond. Intramolecular hydrogen bond. Inter means what? Hydrogen bond between the two molecules, or may same or different, but between the two molecules. But intra means it is the hydrogen bond formed within the molecule. Within the molecule. So in between the molecule means inter. Intra means the hydrogen bond formed within the same molecule is calling as intramolecular hydrogen bonding. I will give you some example. What is that one? For example, ortho nitrophenol will be there. Ortho nitrophenol. Ortho nitrophenol means you can take phenol, O and H, and nitro, N double bond O, and coordinate covalent bond with oxygen. Okay, now what happening? Partially negative here, partially positive. Like that here, partially positive, partially negative, because oxygen is highly electronegative, pulling much towards oxygen, thus by getting negative. Okay, in this molecule, the two groups are very close together, thus by they are attraction together. So how positively charged hydrogen atom and negatively charged oxygen atom having attraction, this hydrogen bond formed between within the same molecule, that's why it's calling as a intramolecular hydrogen bonding. I want to tell you some other example. Orthohydroxybenzaldehyde. Benzaldehyde. You see, already you learned, you take a benzene, on it we are getting orthohydroxybenzaldehyde, no, C double bond O and H, hydroxy OH. Here also the two groups are very close to each other, thus by some special attraction may operating, that is within the same molecule, thus by is calling as the intramolecular hydrogen bonding. Here we are getting partially positive, here we are getting partially negative. Here we are getting partially positive and partially negative. A positively charged hydrogen atom having attraction with negatively charged, that special attraction only we are calling as hydrogen bonding. That hydrogen bonding is happening within the same molecule, so called as intramolecular hydrogen bonding. Can I give, I will give you some other example for this one. Benzoic acid. This is also calling as salicylaldehyde, and this is calling as salicylic acid. salicylic acid. How is this one? Just orthohydroxy benzoic acid. Benzoic acid andre enama benzene, on it we are getting a COOH, benzoic acid. Orthohydroxy, O and H, you know very well, here partially positive, here we are getting partially negative, here we are getting partially positive and partially negative. Orthohydroxy benzoic acid. Positively charged hydrogen atom having attraction with negatively charged oxygen atom, that is happening within the same molecule, so called as intramolecular hydrogen bonding. So we learned so many things, what is the hydrogen bonding and where we are getting, and the types of hydrogen bonding. Because of inter, what is the effect? Because of intra, what are the effects and applications we have to see. All of you understood? Yes. Now see this one carefully. So in between the two molecules we have hydrogen bond, means called as inter. Within the same molecule we have hydrogen bond, means is called as intramolecular hydrogen bonding. Because of inter, what happening among? You may ask a question like this only: why alcohol dissolved in water? Because of intermolecular hydrogen bonding. He may ask the question, why H2O exists in liquid phase? Because of intermolecular hydrogen bonding. We have to discuss about effects of intramolecular hydrogen bonding. Effects of intramolecular hydrogen bonding. Because of intramolecular hydrogen bonding, is there any association of the molecule? No. Why? Intramolecular hydrogen bonding is operating within the same molecule. That's why it will not form any groups. Means no association of the molecules. No association of molecules. Means the molecules, because of intramolecular, no special attraction between the molecule, means they are becoming like a lone single. Okay, because of this one, is there any changes or any improvement in its density and solubility? No. So means we are getting a normal density. No improvement in its density, normal density, and as well as melting point, as well as boiling point, and also we are getting, as usual, solubility we are getting. Because of intramolecular hydrogen bonding, there is no special or there is no extra attraction between the molecule. That's why the molecules are becoming alone. That's why what we are expecting, that one only we are getting. No improvement in its solubility as well as density and viscosity also. Viscosity also as usual. But their viscosity will be going on increasing. Okay, are you understanding? Yes. Now we will see applications of hydrogen bonding. Applications of hydrogen bond. Yes, this is important for both theory and competitive point of view. First point I will explain to you. If you take water is made up of which one? H2O. In H2O, which bond is there? Covalent bond is there. That's why the water is calling as a covalent compound. Generally, covalent compounds is existing in which phase? A gaseous phase. But no, it is existing in which phase? Liquid phase. Generally, covalent compounds are existing in gas phase more, after that liquid phase. So why actually water is the covalent compound? Actually should exist in gas phase but but it is existing in the liquid phase. Reason is what? Reason is nothing but intermolecular hydrogen bond. Intermolecular hydrogen bond.
I already explained 2-3 times. Just once again you see, in water what is the situation? One water molecule, take one more water molecule like this, partially negative, partially positive, between them attraction is coming, that's only we are calling as intermolecular hydrogen bonding. Actually H2O has to be existing in gas phase, but not it is existing in the liquid phase. Why? Between H2O and H2O what happening? Some special attraction is operating, that is only calling as intermolecular hydrogen bonding. Because of intermolecular hydrogen bonding, molecules are close to each other than the matter existing in liquid phase. Are you getting or no? Next point, if you take alcohols, yes, the same reason, alcohols, the two lighter alcohols are soluble in water, lighter alcohols means what? Methyl alcohol, ethyl alcohol, like propyl alcohol. So what is the reason these alcohols can be represented by ROH, common representation. What is the reason? This is reason also nothing but intermolecular hydrogen bonding, only already explained. Take common representation of alcohol ROH, water H2O. Yes, it is dissolving, it is soluble. Why? Some special attraction is operating, that's why they are mixed together. Why? How it is happening? This is partially negative, this is partially positive charge, between them attraction is operating, that is in between the molecule, that's why it is calling as a intermolecular hydrogen bonding. So water is in the liquid phase because of intermolecular hydrogen bonding, and alcohols are soluble in water, that is also responsibility is intermolecular hydrogen bonding. And I want to tell you some other things is nothing but third point, para-hydroxy or otherwise para-nitrophenol is having high boiling point than orthonitrophenol. Orthonitrophenol means the boiling point of para-nitrophenol is more than orthonitrophenol. What are the responsibility we will see? Para-nitrophenol means you have to take the phenol OH, okay, nitro group, N double bond O, and coordinate covalent bond with oxygen. Para-nitrophenol means is there any chance for intra? No. Why? The two groups are well separated, thus by between them there is no chance to get attraction, means there is no chance for intramolecular, but possibility with other molecule attraction. Take it reverse that molecule. This is nothing but N double bond O and coordinate covalent bond with oxygen and OH. You know very well, partially negative, partially positive and partially negative. Here attraction will be coming, here also we are getting attraction. This is calling as a hydrogen bond. Which hydrogen bonding? Intermolecular hydrogen bonding. Intermolecular hydrogen bond. Because of this intramolecular hydrogen bonding, what happening? It is undergoing a association of molecules. Association of molecules is happening. Because of association, if you want to evaporate the liquid, is it happening easily? No. Why? If you want to push the group, required energy will be more. Automatically we can tell boiling point of this one will be high. Thus why these liquids or this cannot be separated by steam distillation. So cannot distilled by steam. So means what? Whenever you are sending hot water to this one, the component cannot be undergoing evaporation because it requires more energy, because intermolecular hydrogen bonding, because association of molecule. No, if you come to orthonitrophenol, in orthonitrophenol, what is the situation? OH and N double bond O and O like this. Here we are getting partially positive and partially negative. Yes, they are very close together, that's why your attraction is coming, that is calling as intramolecular hydrogen bonding. Because of intramolecular hydrogen bonding, is there any chance for association? No association of molecules. No association of molecules. No association of molecules means they are becoming like alone. Alone means disturbing that liquid will be easy or no? Yes, no force or no relation with surrounding.